Hey, we're live.
Cool. All right. What the heck are they?
Is everyone ready to get started?
Yes.
Yeah, I'm ready.
I'm good.
Okay. So, I guess we'll just go over. You guys want to just start with LO4?
Yes.
Yep, sounds good.
This one's pretty short, so.
Both of them were relatively short. 5 just had a lot of practice, didn't it?
Yeah, I think so. That's what it looks like.
Yeah. They made
Like
you
four, yeah.
again and again. Try to beat it into our skulls.
Yeah.
I thought that 5 was a little bit harder for me to wrap my brain around, but I feel like a lot of this other stuff's been more review and there's a little bit more new information on 5, so.
Yeah.
Hopefully I keep up.
Mm-hmm.
Okay, so you guys just want to go over the part 2 and then we can take the quiz?
Yeah, that sounds good.
You want me to vocal again? The vocals?
You're our main guy, so.
Sounds good. All right. 5. A four-sided dot. Are you ready? Okay.
Of course.
All right. 5.
Yeah.
A four-sided die has 4 possible outcomes for each roll. 1, 2, 3, or 4. Calculate the mean for this discrete random variable.
Ashland's with a study group right now, but I will tell her when she's done.
So it gave us a website. Oh, is that just the website where she got the picture? Because I went and it doesn't. I thought maybe we were supposed to roll the die, but it doesn't move.
Yeah, I think it was just supposed to show us that you can roll a 1.
Or maybe what it looks like.
Yeah, I think it's just a picture of it.
So then is it 4 over or 1 over 1 over 4, excuse me, 1 over 4, and then just do that because isn't that what it is?
Yeah, that's what I did.
Yeah.
Yeah, because it's only a quarter. Each value is only a quarter of the die.
Yeah.
Plus the picture was almost not as helpful because the picture itself, it's making me clear. I was a little bit confused for a minute, okay, so are there different odds of you getting the 1 through 4? I'm assuming that it's supposed to be equal chance of getting a 1 through a 4 dice roll.
Yes.
So, is this the population mean that we're looking for?
No.
For number 5 on LO4.
No, are we? We're calculating the probability, right?
Yeah.
Yeah.
And then specifically, they calculate the mean of the discrete random variable. So I started off with just a chart. It's just how I did it.
Was it 1 times 0.25, 2 times 0.25, 3 times 0.25, 4 times 0.25?
For the last column, yeah. So in order to know what probability times the event is, so you can times it by the event, right? You have to get the px first, and then times it x times px. Unless I think I did it right, because I kind of double checked on
the key.
Yeah, just to kind of make sure I was on the right track. But you have to figure out what px is first before you do the next part. But yeah, you're totally right. 1 times 0.05 and then 2 times a quarter, and then 3 times a quarter. And then the sum of all that should be 2.5.
Yeah, correct. That's what I get.
Mm-hmm.
Cool. Cool. And that's all we had to do for 5, right?
I think so. So just 2.5, right?
Yeah, is that 3 cubed? Okay. Do you agree, Ashlyn?
Yeah, sorry. I got it. I was lost for a second just because of myself, but then no, it makes sense. So yeah, that's right. I agree with everything that's inside.
Perfect. You always keep us on track, so.
Yeah.
All right. You guys ready for 6?
I think so.
Calculate the standard deviation of this discrete random variable. All right. Standard deviation. That's is that theta? That's the sign that we're looking at?
I'm not really sure.
Little O.
No, the little M kind of looking sign.
No, I'm talking about like the O with the little swoosh.
Oh,
That's your standard deviation. The M is your mean.
Your meal.
So I thought that this one was a little, like, it looks more confusing than it is, because you really just have to plug in the values. And with the way I made my chart, it makes it a little bit easier just to, like, plug stuff in. So, like, the first column, like, the first value is just the 1 minus the 2.5 squared times the 0.25, right? And then you just kind of go down, doing the same thing, but you just change the value for the x.
Mm-hmm.
Yeah.
Okay, we'll do all that math.
Yeah, we'll just do it each and then talk about what we get, I guess.
Yeah, that sounds good to me.
So then should we make a chart and put, well, I guess because we don't turn it in the homework. So I guess whatever is better for us. Okay, that makes sense.
Yeah. This is more just for working our brains before the test, I think.
Yeah. Excuse me.
Your excuse.
Yeah, thanks. Sorry. Sorry about that. Nasty habit. Trying to stop.
Is that the same cold you had from last week?
Yes, I know, right? No, it's the same one. Yeah, I know. It goes back and forth between like lots of like just straining of my nostrils to a sore throat. So it's lovely.
So sorry. That sounds miserable.
No, it's fine. Luckily, like it doesn't like totally affect like my body. Like I'm not exhausted or tired or feverish. I just cough or sneeze a lot, so that's okay. It's not too bad.
Have you tried Mucinex at all?
No, I haven't. My husband's been giving me like acetaminophen. No,
Sudafed.
Sudafed. Just kidding, Sudafedamine. But so was Sudafed, whatever. So it kind of helps. But then I just get like I drain more, so I don't know.
Well, I would try Mucinex because it's an expectorant, and so it should really help just get all that out.
No, that's smart. I didn't even think about that. So maybe I'm gonna have to go buy some because
I used
it's
to
a
work
nice touch.
and Mucinex is the bomb. So
No, that's awesome.
Did you guys get the standard deviation?
yeah, so my variance was 1.25. Is that what you guys got?
Mm-hmm.
And so
And
after
then you square that.
yeah, so 1.118.
Yep.
Yeah.
I got.
Cool. I wish that they were all that easy. I'm looking. I really struggled with 5, so this should be fun. Contributor.
Well, at least we got done with lesson 4 in about 9 minutes.
I know.
know. It's like record
I'll take
time.
that. We can spend the next 40 minutes struggling through lesson 5.
Do you guys want to do the 4 quiz really quick?
Yeah, I think that'd be good.
So the quiz is going to be a tough one. Wait. Oh. Should we start it?
Yeah. Let. $13 questions, so.
Ooh.
Is everyone in it?
No, it's not. It's not letting
Almost.
me switch from 5.
Okay. Hey, we got the first 2 right.
Yeah. Okay.
All right. You want me to start?
Yes, please.
Give all of your probability answers as decimals. For example, 0.1234. Do not give probability answers as percents. So we probably want to do how many spaces? So 4 or something? Okay. All right. Human blood can be classified into one of 4 basic types, not R. O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. All right. Use this data to answer the following question. The blood types and the proportions given in the table above define a probability distribution.
So we just have to add them together and make sure it equals 1, right?
Yes,
Yeah.
and it does.
It does. Hooray! True?
Yeah.
4.
Alright. What is the probability that a randomly selected person in the United States has type O blood?
0.45, right?
Yep. All right. 5. What is the probability that a randomly selected person will not have type O blood?
It is 1 minus 0.5, so like 5.
All right. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Angle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Assign the following questions, or answer the following questions. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Round to 3 decimal places.
So it's 1/7.
Yeah.
How many decimal
1.43.
places? 3.
3.
So
So 1.43, is that what I got?
3.143.
So wait, 1/7, right?
Yeah.
Yeah.
Right. What was it again?
0.143.
Okay.
Do you think I have to put the 0 in front of the decimal? Oh, I think I have.
I probably would, just in case it's like a glitch if they're still in the blanks.
Okay.
Awesome. 7. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It's very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? There is little evidence that the dogs can detect bladder cancer. But this provides strong evidence that dogs can detect bladder cancer. Bottom one?
I'm trying to like process it and combined total.
So 22 of 54 times. So they say, I mean, like,
That's not half. Oh,
No, that's less than
that's
half.
not half.
Yeah, that's
yeah,
not.
but there's a 0.40 compared to 0.143. It's almost 3 times the amount. I don't know. It says it is very unlikely that the dog would do this well by random chance alone. So I think they're kind of hinting that it provides strong evidence that they can. But maybe not.
I think that, I mean, it's awesome that they can sniff it out, but that's still, like, as a means of identifying cancer, doesn't seem very accurate. But, I mean, what the question is it doesn't ask if it's accurately. It says this gives strong evidence that dogs can detect it, which obviously they can, just not, it's not foolproof,
Yeah.
right? It's not asking how accurate it is. It's just saying that it's
Yeah.
important that they
Yeah.
can.
The statement that it has strong evidence that they can detect doesn't mean that it's foolproof. They're just saying that there's evidence showing that
It's,
it can.
they can. So we should do strong, the first one.
Whichever one says this provides strong evidence that dogs can detect bladder cancer. That's what I would do.
Got it.
Okay. For 8, okay, here we go. M&Ms are small chocolate candies. The M&M's website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given to the following table. If you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy?
So 0.13, right?
Yeah. Yeah.
What is the probability that a randomly selected candy is green? You gotta do 1 minus all of these.
Yeah.
Wait, what did you get for 8?
0.13.
So did you guys get 0.16 for 9?
Yep. That's what I got.
Yeah, that's what I just got.
What'd you guys get?
0.16.
Oh, okay, yeah. That's what I got.
It would be the sum total for everything else, right? The 0.4.
Yep, subtract. What do you say?
Sorry, I read ahead.
Oh,
Sorry,
10?
Matt.
Yeah, the probability that randomly selected candy is not green, and that's the rest of them combined, so you're right, 0.84. You're fine, don't worry. I had already typed it in myself anyways. I was Alright. Alright, is everyone good on 9 and 10?
Yeah.
Yeah.
The ACT scores of students admitted to a medium-sized public university in the western United States were taken from capex.com. The following summary statistics were calculated. Use information from this public university to answer the following questions. 11. Half of the observations are less than or equal to what number?
So don't we just need to take the median?
That's is it? Yeah, that's what I was thinking. Either the median or yeah, maybe.
24?
Because the median would have them in numeric order. So half the observations are less than or equal to the median. So
And then the median is in the half. So
yeah,
24?
24, right?
Yeah.
yeah, that's what I was thinking.
Based on the information of the table above, the top 25% of the students scored above what number?
And that would be the.
First quartile, so above 22.
I thought that if it's the top 25%, it would be the third quartile, which
Yeah,
is
that would be the third quartile, the top
would be correct.
not the bottom quarter.
yeah, the top 25, which would
Oh, just kidding. Yeah.
That's word if you try to catch it like that.
learn. You always write those
Worded
to
on
something
purpose.
around. Then we're good.
So 27?
7 for 12.
Mm-hmm.
Yeah.
So, 13. Which of the following statements is not one of the three rules of probability? Right here.
I'm down.
Let's see. So the probability of an event X is a number between 0 and 1. That's on there.
That's true.
If you list all the outcomes of an experiment, the probability that one of these outcomes will occur is 1. The sum of the possible probabilities is 1. And 3, the probability that an event X will not occur is 1 minus the probability that it will occur.
That's true.
So if the probability is high and the probability is positive, if the probability is low, then the probability is negative. That one.
That's not
Yeah,
true.
that doesn't make any sense.
Well, and they also said, didn't they also say probabilities can't be negative? Yeah.
Yeah, you're totally right. I was like, that doesn't make any sense. So we're submitting, right?
Yep.
Woo!
Hey, we're doing pretty good.
Hooray!
Another A.
We wanted that.
Yeah, we did. Okay, so should we end this one and then I'll send everyone a new request for this one so we can post it?
Yeah.
Yeah, sounds
Okay.
good.
So let me post this one and then I will re-request everything for. Anyway, you'll get another request. I'll see you guys.
Okay.
Yeah.
I'll hang up. Bye.